Hey guys, how's it going? This is part 3 of the AQA Further Maths Paper 1 from June 2017. So, we're finishing off the paper with the last 6 questions here. I think we got all the fun ones to come. Tanked myself up on coffee. Let's do this. So, question 13 wants us to solve x to the minus 1/4 is equal to 0.2. So, first of all, let's take care of that indice. X to the minus 1/4 means 1 over x to the 1/4. Now, 0.2 is the same as 1/5. So, what we can do here, both sides we've got a fraction. On the left, the thing that we want is on the bottom. What we can do, as we have a fraction on both sides, is flip the fractions over. So we will get x to the 1/4 is equal to 5. Doesn't look so scary anymore, I don't think. So how do we undo a power of a quarter? Well, the inverse of a quarter power is to set stuff to the power of 4. So here we want to set both sides to the power of 4. Now that will give us x is equal to 5 to the power of 4. They haven't asked for this to any specific degree of accuracy, so maybe that would be alright, but just to be safe, 5 to the power of 4 means 5 times 5 times 5 times 5. 5 times 5 is 25, times 5 is 125, and 125 times 5 is 625. X is 625. Okay, question 14. Now this looks really fun. So we've got a right angled triangle. We're told BCD along the bottom is a straight line. The length AD is 2√3. We've got two angles in here. We've got a 30° and a 45°, and we want to work out the length of CD. Giving our answer in third form. So let's just highlight what we're trying to find. We are trying to find this length here. How are we going to do that? Well, we're going to fill in as many blanks as we can and hope that we find something useful. So, first of all, we are in a right angled triangle, all told. So, we can actually work out the base length of this right angled triangle, BCD. We can work that out, and we can also work out the height, AB, using SOHCAHTOA. So, we're using this 30° angle, so let's label our triangle. This guy is the hypotenuse, this guy is the opposite. This whole length down here is the adjacent. So, first of all, let's work out the adjacent. So, to work out the adjacent, we're not using SO, we're using CA. CA tells us cos 30 is the adjacent divided by 2√3. Now, cos of 30 is one of our standard trig values. If you can't remember these, I've got 2 videos explaining how to work them out. They're in my higher trigonometry playlist. Can't remember what they're called off by hand. Probably calculating exact trig values. So if you want to check those out, scope them out. Tell you what, I'll put a link to them in the description of this video so you don't have to go searching. How's that? Okay, so cos of 30 is √3/2. So we got √3/2 is equal to the adjacent divided by 2√3. So if we then multiply by 2√3, we're going to get 2√3 3 divided by 2 is our adjacent. So root 3 is 3. 2 times 3 is 6. Divide that by 2, we get the adjacent is equal to 3. So what we now know then is the length along the bottom is 3. So that's that whole length BCD is equal to 3. Okay, so that's nice. That's a nice whole number. That makes me happy. So, well, like I said before, we can also work out the height of this whole triangle. Always called it a rectangle. That's good. So this time using that 30-degree angle, we would now be doing SOT. So SOT tells us sine of 30 is the opposite divided by the hypotenuse, so O over 2 root 3. Sine of 30 is 1/2. So 1/2 is the opposite over 2 root 3. If we multiply both sides by 2 root 3, we just get root 3 is equal to the opposite. So we now know the height of this triangle is root 3. So I'm going to clear things up and then we can see what else we can do. So let me just zoom out so you can see all of that in one place before I delete it. Okay, so let's clear all of this up. So we now know that the whole base of this triangle BCD is 3. We now know the height is root 3. So what we can now do in this left hand triangle, we can work out the length BC, again using trigonometry. So root 3 is the opposite, the base is the adjacent to that 45-degree angle. Now we're playing with tan, so it's TOA. TOA tells us tan of 45 is root 3 over the adjacent. Now tan of 45 is just 1, so we've actually just got A is root 3. So now we know this little bit of that bottom line is root 3. So CD is the whole line BCD 3 minus BC. So minus root 3. That's our answer. 3 minus root 3. Tricky question. Quite fun though. Okay, question 15. We're told information about a curve and its stationary points and the amount of places it hits the x-axis. So a curve has exactly 3 stationary points. We've got one minimum point P, which has coordinates A, B, where A is less than 0 and B is less than 0. So let's talk about each point one at a time. So P is a minimum, so that means it's like an unhappy, it's like a happy smile basically. Now we're told the coordinates of this point are A, B. Now A is less than 0 and B is less than 0. So in other words, we are in the negative x and y part of the graph. So point P is going to be down here somewhere in that portion of the graph. So then we're told we've got a point of inflection, which is point Q, which has coordinates 0, 3. So Q is going to be somewhere on the y-axis. Let's put Q here at the moment. So our point of inflection is sort of, let's just explain it. When your graph sort of goes like this and like that, that point there where it has no gradient is a point of inflection. So we're going to have that sort of thing going on the y-axis. And then finally we've got point R, which is a maximum, which has coordinates C, D, where C is greater than 0 and D is greater than 3. So that is going to be, say that this point is our y-intercept, then point R is going to be over here somewhere. So the x-coordinate is positive and the y-coordinate is greater than 3. So we are also told the graph cuts the x-axis in exactly 3 points. We want to sketch our graph. So I'm not the world's best drawer. I'll try and do this as well as possible. So it's going to be something like this. It's going to go down like that to a minimum point at P. It's going to go up to our point of inflection here on the y-axis, and it goes up to our maximum at R, and then it's going to go down through the x-axis again like that. So we then got our 3 points where it cuts the x-axis, there and there. We've got our point P down there, which is a minimum. We've got our point of inflection on the y-axis, which has coordinates 0, 3, and then we've got our maximum point up here, R, which is at C, D. So again, the x-coordinate is positive and greater than 0, and the y-coordinate is greater than 3. So our graph is going to look something like that. Okay, question 16, we got some sine rule up front. So we got this triangle, we've got one angle of 120 degrees, we've got one side length of 6 centimetres, one of y centimetres, and one angle of x. So we're told that sine of x is 1 over root 12. So, and our mission is to find the size of y. So, let's label our triangle. Let's call this angle A, and this is side A, this angle B. So then this guy is side B. So by the sine rule, we're looking for a side length. So we're going to use the sine rule as A over sine A is B over sine B, like that. So if we work our stuff in, we're going to get 6 over sine of x, but we know sine of x is 1 over root 12. So 6 over 1 over root 12 is equal to y over sine 120. So this is what we're playing with. You can figure out the triangle now. Now 6 divided by 1 over root 12. Well, remember, when you divide by a fraction, which is what we're doing here, you flip it over and multiply by it. So on the left we've actually got 6 root 12. Now on the right we've got y over sine 120. So we can get that y is equal to sine 120 times 6 root 12. Okay, so we've got some more, even though that is what y is equal to, we should probably sort this out and simplify it. So we got some more fun with standard trig values. The sine of 120 is, let's just sketch the graph of sine. So it looks like this, up to 180 degrees. We've got the maximum point at 90 degrees. So we've got 60 degrees here and 120 degrees here. So the value of sine of 120, sine of 120 is equal to sine of 60. Sine of 60 is root 3 over 2. So on the left we've actually got root 3 over 2 times 6 root 12. Okay, times. So let's change colour because it's all blurring into one. Now we've just got some fun with surds. So we've got root 3 over 2 times 6, or root 12 is root 4 root 3. So times 6 root 4 root 3. So we've got root 3 over 2 times root 4 is 2. So we've got 6 times 2 root 3. So we've got 12 root 3. So if we combine it all, we're actually going to get a nice answer. We have got 12 root 3 all over 2. Now root 3 is 3. So we've got 12 times 3 on top, which is 36. Divided by 2 is 18 centimetres. Lovely jubbly. Okay, question 17, we're nearly there guys. We want to factorise 2x squared plus 7x plus 5. So, we want two sets of brackets. One of them is going to have a 2x and the other an x. Now we need two numbers that multiply to 5, such that they multiply 2x and x to add together to give us 7x. So, we don't have many possibilities when it comes to 5. We've only got 1 and 5. So we're going to have 2x plus 5 in there and x plus 1 in there. So then 5 times x is 5x, 1 times 2x is 2x, 5x at 2x on a good day is 7x. Jobs are good for part A. Okay, and then for part 2, hence or otherwise, find the value of theta, for which 2 sine squared theta plus 7 sine theta plus 5 is equal to 0. So this might seem completely unrelated to what we've got just done. Basically, we're just making the substitution. X is sine theta. So up above, we had 2x plus 5 times x plus 1. So if we set that equal to 0, then our solutions for x, well, we would get either 2x plus 5 is equal to 0, so 2x equals minus 5, so x would equal minus 5 over 2, or by this bracket on the right, we would get x is equal to minus 1. So what we are actually solving here is either sine theta equals minus 5 over 2, But remember, sine values can only oscillate between +1 and -1. So sine theta being equal to -5/2 doesn't make sense, because that's -2.5. So that has no solution. So, quite happily, we can say goodbye to that equation. So what we actually want to solve is sine theta equal to -1 between 0 and 360 degrees. So let's sketch the graph. It's the cool thing to do. There's our lovely graph. Maximum point of 1. More importantly though, minimum value of -1. So the point where the graph goes through the x-axis is 180. This is 360 over here. This point is exactly halfway between 180 and 360, which is 270 degrees. So theta is 270 degrees. Okay, one more question, guys. Okay, final question. We got this triumphantly evil bastard. Look at it. We're going to have so much fun with this guy. What we're going to do, we're going to go nice and slowly, step by step, take our time. So, deep breath. Let's go. Okay, so we want to simplify this guy fully. Now, the first thing we need to do is rationalize the denominator. For more examples on questions like this, search out my third playlist. So, right then, to rationalize a denominator like this, we use the difference of two squares. So if we've got 4√3 minus 5, we multiply by 4√3 plus 5. And we do that on the top and bottom. Like that. So what we're going to do, we're going to do each multiplication separately. So let's do the top first, because it's the trickier of the two. So we are going to do 24 minus √300 times 4√3 plus 5. Good times. Now then, the way that I would recommend doing this is absolutely by using a table. Like this. So, 24 and minus √300 down the side like that. And then 4√3 plus 5 across the top. Right then, 24 times 4√3. Well, 24 times 4 is 96. So we get 96√3 in there. Lovely. Then 24 times 5 is 120. Now we've got 4√3 times minus √300. So the third terms can combine there and give us minus 4√900. And then we've got minus √300 times 5. So that's going to give us minus 5√300. How lovely. Right. Next, let's take things out of this and try and simplify as much as we can. So, can we at all? Hopefully. So, let's actually take each separate term out and simplify it, first of all. So, we got 96 root 3. That's as simple as that can be. Then we've got minus 4 root 900. Now we can simplify 900 or root 900. It's actually a square number. 900 is 30 times 30. So, minus 4 root 900 is minus 4 times 30, which is minus 120. So, there's that sorted out. Then we need to sort out now minus 5 root 300. Okay, so to do that, well, minus 5 root 300, we can write that as minus 5 root 100 root 3, like that. Now root 100 is 10, so we've got minus 5 times 10 root 3, which gives us minus 50 root 3. So we've simplified all the terms. Now we can get our expression. So what have we got then? We got 96 root 3. Then we've got plus 120, but we've also then got this minus 120, so they're going to cancel out, and then we've got minus 50 root 3. So remember, this is just the top of our fraction, so the 120s cancel out. We got 96 root 3 minus 50 root 3. We're just left then with 46 root 3. Good times. Okay, we're going to clear that up. Now we'll sort out the bottom of the fraction. Okay, so the top of our fraction is 46 root 3. We now need to sort out the bottom. So again, we're multiplying that by 4 root 3 plus 5. Now this is slightly simpler. When we use the difference of two squares, we get the first term squared minus the second term squared. So here, we're going to get 4 root 3 squared, which is 4 root 3 times 4 root 3 minus 5 squared, so minus 25. So 4 root 3 times 4 root 3. Well, we can think of that as 4 times 4 times root 3 minus 25. 4 times 4 is 16, so we got 16 times 3 minus 25. 16 times 3 is 48. Minus 25 leaves us with 23. So we can now finish the question. The whole fraction is the top over the bottom. So we've got 46 root 3 over 23. 46 divided by 23 is 2. So believe it or not, our answer is just 2 root 3. Okay guys, I hope you found that useful. If so, let me know down below. Do you want me to do paper 2? Are you going on to do A-level? I'd love to know, because I'm going to start doing A-level lessons over the summer. Hope you found this useful guys. Take care, good luck.